Keeping golf courses or other outdoor recreation facilities functioning and looking their finest often involves the use of chemical pesticide or fertilizer products being applied with a boom sprayer. When sprayers are used without regular calibration, you risk over or under applying these products, which can lead to problems such as damaged foliage, soil contamination, and even pesticide-resistant insects and weeds, not to mention the financial cost of wasted chemicals. With this simple worksheet, you'll be able to see to it that your boom sprayer is functioning as it should and in a cost-effective manner. These are also valuable records that can be used each season to track expenses as well as the effectiveness of a given sprayer or application program. Like most calibration procedures, we'll measure a small sample in order to determine the total output over your entire acreage. First, let's take note of the equipment being calibrated. The first part of the worksheet gathers the basic identification information, along with the date, operator, location, and equipment being used for the calibration. Because the calculations are based on a sample size plot of your grounds, you'll be traveling a measured course, preferably a level, straight stretch, with conditions similar to the area targeted for spraying. The measured distance will be based on the width between nozzles on your boom. The worksheet offers a chart providing the travel distance. For example, for a boom with nozzles measuring 20 inches apart, the power unit will be timed on a course measuring 204 feet in length. The power unit should be pulling a clean sprayer tank filled halfway to represent an average weight load. Take note of the power unit's details, such as the power unit make and model, tires brand, the gear it's being driven in, as well as the RPM. Also, record the tire size and height from the ground to top of tire. And remember to record the sprayer make and model, tank size, and pump pressure. Measure the distance using assistance to record the time it takes to travel the course once down and once back. Record it twice, then average the two times in order to establish an average time. If the first two measured times have more than a 10% differential, it may be necessary to repeat the timing tests. In this test, the time was 29 seconds for the first run and 26 seconds for the second run, for an average of 27.5 seconds. Next, we'll convert the recorded times into miles per hour and speed per minute as part of determining how many feet per minute are being covered and consequently how much product is being applied at each foot. Calculate the distance in feet multiplied by 60. Then divide that number by the 27.5 seconds multiplied by 88. This will give you your miles per hour number, which is 5.06. With the power unit in a stationary position, set the same engine RPM used in the timing run. Also, set the application pressure that you normally use and spray water through the boom. If you're using a sprayer with a comptroller like this unit, refer to the operating manual for proper RPM and pressure measurements and any other settings to use during calibration. Collect spray at the nozzles when all the nozzles appear to have a uniform delivery at the desired PSI. The container should be quickly placed under each nozzle for the 27.5 seconds recorded during the timing run. As part of the worksheet, you'll find this chart for recording the collected output of material over the previously measured time. Take note of the nozzle and tip sizes being used on the boom. Again, make sure that the sprayer tank has been cleaned and filled with clean water. No one wants to be exposed even to minimal amounts of chemical product during testing. For the same amount of time recorded in your measured distance test, record in ounces the collected output for each individual spray head. If the test time is too long for containing the output, cut the time in half and multiply appropriately to determine the output for the full test time. While collecting the water during the timed output, the presence of faulty tips or nozzles will be evident by the amount of fluid being released. If any individual head output indicates a deviation of more than 10% of the average output, it may be time to double-check the nozzle for damage or incorrect labeling and should be replaced. By adding the total output, you will be able to determine the total amount of product sprayed during the measured length. Take the total and divide that figure by the number of nozzles on the boom for an average output per nozzle. In this example, the average output was 53.9 ounces per nozzle. Determine the minimal output by multiplying the average output by 0.9 for 48.5 ounces, and calculate the maximum output by multiplying the average output by 1.1, or 59.3 ounces. Replace all of the boom nozzles if the average output measures 15% more than a new nozzle's output, based on the manufacturer's chart or discharge test. The ounces collected during the timed collection directly translates to the number of gallons being applied per acre. So, 53.9 ounces translates to 53.9 gallons being applied per acre. Knowing with certainty the amount of product being applied is the best tool for keeping your equipment running productively and cost-effectively, and will provide the desired results at your facility each and every time.